I'm Lee. We are now studying test hypothesis, chapter 5. There are two hypotheses, H0 and H1. And there exists only one test statistic to test hypothesis that will be best estimator of that parameter. And we have to understand rejection region for H0. What is this? Rejection region for H0. The rejection region is the range of values of test statistic where we may reject H0. Okay? And another important concept or terminology is significance level, alpha. Is this alpha, okay, is the probability of uh, error. What kind of error? Even though H0 is correct, we reject H0, then we make error. That kind of thing is type 1 error, and alpha is probability of type 1 error. Okay, so far so good. Now let's see testing hypothesis for population mean mu. Okay, this is the most important part here. If you understand this part, then no worry about other parameters. Okay, here I want to start with two-sided test case, two-tailed test. Let's perform a two-tailed test on population mean mu. For example, we want to test whether the average weight of potatoes being cultivated before harvest on a potato field is 50. We want to test the average of potato is 50 or not. In this case, the test statistic should be x1. You should not use other test statistic because it is about the what population mean. Let's assume we obtain a sample of n potatoes. Then we will take n potatoes. Hypotheses are H0 is mu equal to 50 versus H1 is mu is not equal to 50. Okay, two hypotheses. This is important. Under the assumption H0 is correct. Okay, the average weight is mu is what? 50. That is correct. Okay, that is an assumption, pre-assumption. The distribution of a sample mean x bar follows as follows. Yeah, x bar has normal distribution. H0 is correct. Then mu equal to 50 variance sigma square over n. You know that. And when standardized, it becomes g x bar minus 50 over sigma over square root of n. Right? It is a standard normal distribution. However, since the deviation sigma is unknown, we must estimate it using the sample, say standard deviation s, and we substitute it for sigma. Then g becomes different random variable t. Okay, t equal to x bar minus 50 over s divided by square root of n. We studied this when we studied sample mean, okay? Not really sample mean, confidence interval for mu. Okay, that has follows t distribution with degrees of freedom n minus 1. What is the degrees of freedom over here? It is from degrees of freedom of s. Now, from alpha is what? H0 is correct, given H0 reject. We say type 1 error, this one, and the probability of type 1 error is alpha, right? So what is H0 correct? Mu equal to mu 0. Mu equal to mu 0 given H0 reject. So how about the 1 minus alpha? If alpha is like this, then H0 accepted. 1 minus alpha is mu equal to mu 0 under this condition, H0 accepted. What is this? 1 minus alpha. 1 minus alpha is the confidence level for mu. We use this kind of equation. Okay, 1 minus alpha equal to t probability of t greater than equal to minus t alpha over 2 less than t alpha over 2. Difference is here. mu equal to mu 0. Okay? Because now we are studying test hypothesis. This is assumption, pre-assumption. Okay, then we substitute mu 0 here in, oh, t is this one, and we substitute mu 0 here. Okay, then this equation we get. If you see slowly, then even though you don't have a mathematical background, you understand this flows. Now, we left x bar in center and rearrange the items. Okay, then this is probability x bar greater than or equal to mu 0 minus t alpha over 2 times s over square root n, same value plus here. Okay, it is simple. So what is alpha then? Alpha is the other area of x bar. The other area of x bar is what? X bar less than this one, mu 0 minus t alpha over 2 times s over square root n, and or x bar greater than this value, right? Okay, then now we'll have to make this result simpler than x bar minus mu 0 divided by s over square root n less than minus t alpha over 2, or same thing here. Okay, so this is rejection region for H0. Rejection region for H0 is what? Okay, here, let's say this kind of a graph, x bar here. The mean is mu 0 because assumption H0 is correct. So population mean is mu 0. We get sample from this population, okay? Population. There are many x bar possible. Different values, sometimes same values. Then it will distribute it like this. The center is mu 0, right? Mean. Then if you get sample mean here is mu 0 minus t alpha over 2 times s over square root n. Okay, this value less than that, then you may reject H0. Even though this value, sample mean, is from the population with mean mu 0. This way, same thing. You understand that? Okay, you better think about that, then you will understand. Or if I think it is necessary, then I will repeat. I will review a little bit next time. Okay, thank you. Bye.